Hello everyone. In this lecture I shall discuss the uniqueness of Laplace transforms. Okay, I will basically discuss the uniqueness of Laplace transforms. Now let me to first recall the existence of Laplace transforms. If you recall the definition of Laplace transform, it is integral 0 to infinity e to the power minus st into ft dt. After evaluation of the integral, in place of t we are going to substitute 0 and infinity. So it will purely a function of s here, right? Now this integral exists. Okay, it is subject to the existence of the integral. It is subject to the existence of this is an improper integral because of the infinite limit. Existence of the improper integral. Okay, integral. However, there is a separate criterion for the existence of Laplace transform, right? Existence condition. This is sufficient condition. The details you can view from this previous lecture, right? A function ft be such that number 1, ft is piecewise continuous. Number 2, ft mod less than equal to m e to the power kt. M and k constants, that is exponential bounded. That is ft is exponentially bounded. Then L of ft exists as long as s greater than your k. So this k here, okay, so s greater than is equal to k. So this is the existence criterion, means this condition is sufficient, means even if this condition doesn't hold, right, then also Laplace transform exists. You can see the details from this previous lecture. Now let me to discuss the uniqueness criterion. Before that, let me to introduce myself. Professor S.K. Paikray, Kumar Paikray, currently working as a professor of mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. So without much delay, let me to tell the uniqueness criterion of Laplace transforms. So before the details of discussion of the uniqueness criterion, let me to ask you one example. Suppose your ft is equal to 1, 0 less than equal to t less than 3 and 0 t greater than 3. Another function is my gt is equal to 1, 0 less than equal to t less than equal to 3 and 0 t greater than 3. You see both of these functions. So here it is less than equal and here it is strictly equal. So you see these two functions are certainly not equal, or in fact we say ft is not equal to gt, or we say ft is equal to gt almost everywhere, means throughout it is same except at t is equal to 3. That means I can say that is ft is equal to gt everywhere except at t is equal to 3, right? However, in general they are not equal. But if we want to find the Laplace transform of both the cases, if I find the Laplace transform of L of ft, which will be same thing at Laplace transformation of g of t, right? So it will be integral 0 to 3 e to the power minus st, right, into 1 dt in both the cases, right, irrespective of the single point. So here this is the case. Now if you simplify it, it will be minus 1 by s e to the power minus st from 0 to 3. So this is equal to minus 1 by s e to the power minus 3s minus 1. So this is 1 minus e to the power minus 3s divided by s, right? provided here s is greater than 0. Now you see here ft is not equal to, so what we obtain? Clearly ft is not equal to gt in general, right? However L of ft is equal to L of gt, right? That means two different functions have the same Laplace transforms. Two different functions have same Laplace transforms, right? But if two functions are continuous, they cannot have, right? However, so this is possible only when the function is piecewise continuous. But once the functions are continuous, okay, then the same Laplace transforms lead to the identical functions, right? Once the function is continuous, if two continuous functions have same Laplace transforms, then they are completely identical, right? So if they are continuous, right, then they are completely identical. However, if they are piecewise continuous with exception at a singular point, then we may have different functions with same Laplace transforms. So in general, what we can write? So consequently, we have, if two functions have the same Laplace transforms, then they are equal almost everywhere. I write a dot e dot. So what does it mean? Almost everywhere. What does it mean? Almost everywhere means, right, two functions differ only at singular points. At these singular points are finitely many, and possibly these are the point of JAM discontinuity. Possibly these are the points of, as we see, it is at the JAM discontinuity only, okay? They differ only at the JAM discontinuity. So this is the criterion here. Two functions have the same Laplace transforms, then they are equal almost everywhere, not exactly throughout, right? In continuous case, they equal. In discontinuous case, they vary at the point of JAM discontinuity. So, right. So, to simplify, consequently what we can say, if two continuous functions have same Laplace transform, then they are completely identical. So this is the case of continuity. Now if two functions are piecewise continuous, right, you see mark, it is piecewise continuous and here it is continuous, right? Then it is possible that two different functions have same Laplace transforms, as we see this case, right? This is different function, but we are getting the same Laplace transforms, right? We are getting the same Laplace transforms. So moreover, these two functions, possibility for only at the point of jump discontinuities, right? Finitely many. So these are finitely many, and these are also called the singular points. Finitely many such singular points. Okay, singular points. Finitely many such singular points. Okay. So to conclude, if two functions have same Laplace transforms, then they are equal almost everywhere. So almost everywhere means they may differ at the point of jump discontinuity. Now to classify, if two functions are continuous having same Laplace transforms, if two continuous functions have same Laplace transforms, then they are completely same. However, if they are piecewise continuous, then it is possible that they may have different Laplace transforms. Okay, different functions have the same Laplace transforms, and this difference is due to the point of jump discontinuity only. Okay, so with this, let me to close the lecture here. If you feel the lecture is useful and interesting, right, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures to your benefit. So thank you all. Have a nice day.